Okay, so we should be live now. Sorry about that. There was a small issue with YouTube Live. So welcome everyone to the third coding workshop. I'm Christos, and as per usual, I've pre-recorded the workshop just to make sure that everything goes smoothly. So I'll be around to answer any questions in the chat as we go along. So if you do have any questions, just fire them there. And yeah, without further ado, let's get started. Hello and welcome everyone to the third Linera coding workshop. I'm Christos, I'm a software engineer at Linera, and in the previous workshops, we've been building our fungible token application, something a little bit like an ERC20 token. If you haven't seen the previous videos, you should probably go check them out. The link should be in the description. Also, if you want to follow along, there should be a link to a GitHub repository with all the code that we're working on. In the first workshop, we created our fungible token application, and we built the so-called transfer operation where you can transfer funds from an account on chain A to a different account on chain B. However, we don't currently have a mechanism to withdraw funds or claim funds, that is, funds that we own on a different chain to bring them onto our own chain. And that's what we're going to be doing today. So the first thing is we're going to be working on the claim operation to claim funds from a different chain. And the second thing is we're going to enable application calls so that other applications can call our fungible token application and use all of its functionality. Okay, so let's start by building out the claim operation. So the claim operation is it's going to enable a chain owner to claim a certain amount of tokens from a source account, which is an account. Because remember, we're claiming from money which is potentially on a different chain. We're claiming a certain amount, and we are sending that money to a target account. Okay, perfect. Now we're going to go into contract, and the compiler should be telling us that, yep, we haven't exhaustively matched an operation. So we're going to do that here. We're going to destructure the operation claim, so source account, amount, target account. And what we're going to do is something very similar to transfer. We're going to, first of all, check if we are authenticated to claim from the account. So what is it? Check account authentication. And we're going to say context.authenticated signer, and make sure that the signer is the source account, the money that we're pulling, the account that we're pulling the tokens from. So what do you not like here? Oh, right, this is an owner, so we're going to do .owner here. Perfect. Okay. We also want to return the result if the authentication fails. And then what we're going to do is we're going to say self.claim source account, amount, and target account. And this is an asynchronous function which we haven't defined yet. So let's define that now. Okay, so let's define our claim function. So the claim function is going to be making a cross-chain call. It's going to be sending a cross-chain message, so it's going to be asynchronous. And we're going to define the claim function with the same signature as the claim variant. So we're taking immutable reference to self. We have a source account, an amount, and a target account, which we are account. And we're going to be returning an execution result of type. No, it's a result. Yeah, it's a result type execution result, where the OK variant is execution result message, and the error variant is just our error here. Perfect. So in order to claim funds, first of all, we want to check that the source chain, if the source chain is the current chain, then we're just going to debit the funds locally and send a cross-chain message to credit the funds on the target account. On the other hand, if the chain is a different one than the one that we're currently on, we're going to send a cross-chain message to to withdraw the funds from the target chain. So let's check our source account is equal to current chain ID. What we're going to do is we're going to debit the funds from our local state, so source account dot owner, a given amount, and again this is asynchronous. And then finally we're going to finish transfer to account. Again, this is the method we defined last time, so we're going to be crediting the target account. Perfect. Now else, so if the source account chain ID, this should be chain ID here, chain ID is not the current chain, what we're going to do is we're going to define a new message, and it's going to be a message withdraw, which we don't have yet, and we're going to define that now. So withdraw, and let's head over to librs to expand our message definition here. So our withdraw message has an owner, so owner, an amount, and a target account, which is an account. Perfect. Okay, so let's head back to our claim operation, message withdraw. Now our ID can help us fill out the fields. And the owner here is the source account owner. The amount is the amount, and the target account is the target account. Perfect. And finally, what we're going to do is we are going to send this cross-chain message. And finally, we're going to return OK, execution result default with authenticated message. And we're going to give it the source account chain ID and the message to withdraw the funds. And that's our claim operation done. Now, one thing we haven't done yet is pattern match on receiving the withdraw message. So let's add that pattern now. Again, we're just gonna destructure it here. And so if we have an incoming message to withdraw funds from a given account, the first thing we want to do is check that the signer of the message has the permissions to do this. So what we're going to do is we're going to use our self check account authentication method, and we're going to get the signer of the message, context of authenticated signer, and we're going to make sure that that's equal to the owner of the funds. And if it's not, we don't want to allow this message to withdraw funds, right? Next, what we're going to do is, once authentication is passed, is we're going to debit the funds from the owner. So we're going to debit an owner for a given amount. And we're going to await this because it's asynchronous. And finally, what we're going to do is we're going to finish transfer to account for a given amount to the target account. So at this point, we've debited the funds, but we need to credit them on a different account. So we're going to send another cross-chain message to debit those funds, to credit those funds. And this is asynchronous, so I'm going to await this. And let's just cargo build and see if this all compiles nicely. And it does. So this is how we implement the claim operation, which enables chain owners to claim funds from their account on a different chain. Okay, so now that we've defined our claim operation and our withdraw message, we are ready to expose our fungible token application to other applications. That is, enable other applications to use our fungible token application. So in order to do this, the first thing that we want to do is we need to change the semantics of our application a little bit. Specifically, our fungible token state has a set of accounts, which is a map from an address to an amount. Now, if we want applications to be able to store, to have accounts on our fungible token app, we need to change this definition right here. And to do that, what we're going to do is we're going to head back into librs, and we are going to define an enum called account owner, where an account owner is either a user, so an owner, or it's an application, which has some tokens in our application. So this is going to be an application ID, which is a unique identifier for an application. And we are quickly going to derive the same set of things here that we had for our account. And what we're going to do next is we're going to change a lot of references of owner to account owner. So let's just do that real quick. So this is an account owner. This here is an account owner. Creating an account owner. And we're transferring from an account owner. Perfect. Okay, so now that we've changed our operations and messages to work with account owner, let's update our state. What we're going to do first is we're going to change this key in our map from owner to account owner. And we're going to replace all of these occurrences of owner to account owner. And we're also going to change our logging logic to use debug instead of display, because account owner doesn't have a nice display function, but it will print out. We have derived debug. Okay, so now that we've updated our state, let's head over to the contract. So here we need to change a bunch of different things, but the first thing we want to do is now we have a little bit more sophisticated account authentication. The reason being that we're either authenticating an application or we're authenticating a user. So let's just head over to check account authentication, and we'll change this definition to take an authenticated application ID option, application ID. Okay, so now what we're going to do is we're going to pattern match on the owner here, which is now an account owner. What we're going to do is match owner. Actually, yeah. So, and what we're going to do is, first of all, we're going to match against the account owner variant. We'll call this address. If authenticated signer, this shouldn't be signed, this should be signer, equals some address. So if our authenticated signer is the same as the address that we're, for example, pulling money from, and if that is the case, we're going to return the OK result. OK. Perfect. Next, we're going to say, OK, so if our account owner application, give it an application ID, and if that is the same as the authenticated application ID, then again, we are very happy here. However, if we match on anything else, we are going to error that we have the incorrect authentication. Yep, okay. And that's our check account authentication method done. Okay, now let's make sure that everything compiles, because again, the change from account to account owner is probably going to cause some compilation issues. Like for example here, this should be account owner user variant wrapping the owner. In this case, what we have here is none, 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 and we should be good. Let's try cargo build and see what happens. Okay, we have 3 errors. That's fair enough. Okay, so in order to get account owner to play nicely with GraphQL, we're going to define it as a scalar, which essentially means a scalar is basically a leaf of a GraphQL schema. So it's something that isn't decomposable into anything more primitive. And let's see if the compiler is now happy. Okay, so we're missing something here. Right, yeah. So service. And right, this should be account owner as well in our service. Okay, perfect. And that is the move from account to account owner done. Okay, so now that our fungible token state supports applications storing funds, let's define our application calls. So to do that, we're going to extend our application binary interface and add the application call, well, define that the application call associated type is of type application call. And let's quickly define application call. So pub enum application call. Perfect. And we're going to derive, debug, serialize, and serialize. And our application call enum has three variants. The first is the balance variant, where we're checking, well, an application can check what is the balance of a given owner. The next is the transfer variant, which is identical to our transfer variant under operation, where an application can transfer funds from one account to another. And finally, we have the claim operation for our application, where an application can claim a certain amount of tokens. Perfect. So now that we've defined our application called enum, what we want is we want to now applications that import our fungible token application as a crate can access these types and can make these calls, and what we have to do is now handle them. So let's head over to the contract and handle application calls. Okay, so to handle application calls, what we're going to do is we are going to remove the underscore from context and call because we're going to be using them. And we are going to match on the application call, on the incoming application call. Add remaining patterns. Okay, so let's start with balance, which is the simplest. What we're going to do is we are going to initialize our application call result. So we'll call it res equals application call result default. And what we're going to do is we're just going to query the balance from our state as per usual, equals self dot balance given the owner, and we're going to await. And this is infallible, so it's just a semicolon. We're going to append the balance to our result. So res.value equals balance. And we are going to say OK, where we pass the result. And I'm just going to put unimplemented here and unimplemented, just to make sure that we can compile this cargo build. OK. So, okay, what we need to do here is we need to go back into our librs, and we haven't defined the response type here. And our response type here should be just an amount. Let's cargo build again. Perfect, and that all works. So now let's handle the application call transfer. What we're going to do is we are going to first of all, destructure the transfer operation. So, and then what we're going to do is we're going to check the account authentication that this application can indeed transfer funds. So check account authentication. And we're going to check that the context.authenticated caller ID, context.authenticated signer, which should be none, and the owner. So this is going to check that indeed the application that's making this call can transfer money from this account. So then we're going to self.debit the amount from our account for a given owner, the amount, await. And finally, we're going to just do the old self.finish transfer to account, where we're going to credit a given amount to a given account, probably on a different chain. And we're going to await. Okay. So the compiler is complaining here. Okay, mismatch types. Okay, that's fair enough, because finish transfer to account is returning an execution result, where what we really want is an application call result. So we're going to define our result again here. Let meet res equals application call result default. Then we're going to get the execution result here. And what we're going to do is we're going to attach the execution result to our application call result. Equals execution res, and then we are going to return our result. Perfect. And the compiler is happy. Awesome. So finally, let's implement our claim application, where this is going to be similar logic to our operation claim, but this time, again, we're checking the application authentication as well. So destructuring, add missing fields, self, check, what is this? Check account authentication. We're going to give it the authenticated caller ID, authenticated signer, and the owner, source account in this case, dot owner. Okay. Next, we're going to perform the claim operation that we defined earlier, which is going to give us an execution result. So let's first define the application call result as usual. Make res equals application call result default, and then let execution result equals res equals self dot claim, and our claim operation takes a source account, an amount, and a target account. So here you can see as well why we have why claim is its own method, because it's used twice, by the claim operation and by the application claim. Perfect. And now we can put the execution result back into our application call result and return the whole thing. Cool. So I'm just going to cargo fix to remove the unused imports. Okay, so that's our application call logic done. We've now implemented the types and the code required to enable other applications to call into our fungible token application and use it. Next time, what we're going to be doing is we're actually going to write a small example where an application is calling the fungible token application and using it. So we're going to see how all that works. Thank you very, very much for watching, and see you next time.